Here is a sequence of numbers. Sequence just means a list. So for example, 11, 15, 19, 23. This is a sequence. The first number is called the first term. This one is the second term, and so forth. So we can call this term 3, and this one term 4. Let's say we want to find the fifth term of this sequence. Okay, so we want to find the fifth term. To go from term 1 to term 2, we can add 4. 11 plus 4 is 15. 15 plus 4 is 19. 19 plus 4 is 23. 23 plus 4 is 27. So that's why the answer is 27. That's it. Next, write an expression that can be used to find the nth term of a sequence. Expression here means formula, like something that you can use to find any term. Nth term just means any term. Okay. Well, okay. Term 1 is right here, 11. Term 2 is 15. How do we get that? That's 11 plus 4. Right. Term 3 is 19. That's 11 plus 4 plus 4 again. 23, that's term 4. That's 11 plus 4 plus 4 plus 4. Now, as the number of terms go up, we'll have a lot of plus 4s, right? Is there a way to simplify this? Well, yes. Plus 4 plus 4 plus 4, there are 3 plus 4s here. So that's the same as 4 times 3. 4 plus 4, there are 2 plus 4s here. So that's just 4 times 2. So really, this one would be 11. The green one is 11 plus 4 times 1. And really, this pattern holds. Even for the first term, we can write 11 plus 4 times 0. Now we see a pattern. For term 1, it's 11 plus 4 times 0. For term 2, it's 11 plus 4 times 1. Term 3, we times 2. Term 4, we times 3. So for term n, it's still going to be 11 plus 4, but we're going to multiply by n minus 1. Okay? So here is our expression, a formula. 11 plus 4 times n minus 1. Okay? So what do we learn? Well, given the sequence 11, 15, 19, 23, our expression looks like 11 plus 4 times n minus 1. That's just for this one. In fact, for any expression, we can use a sub n equals a sub 1 plus d times n minus 1. Notice that there's really a multiplication here, but we don't really have to write it because when there's no multiplication, it means multiply. So this is d times n minus 1. This is the nth term, any term. This is the first term. This is the common difference. Common difference means how much we're going up every time. So in this sequence, we're going up by 4, so d is 4. And 11 is the first term. Okay? Now here I have to mention that there's other formulas you can use that are equivalent. It means they are really the same. You can also use this one. Which is really similar to the first one, except we use a sub 0. A sub 0 means we have to go back 1, which means it will be 7. That will be a sub 0, the 0th term. But that's the same thing as dn plus a0. And that's actually the same as y equals mx plus b, which we have seen in Unit 2. The 0th term is just the y-intercept. The difference is the slope. And then the other numbers are y and x. So we can use any of these formulas to write our expression. Here's one. That one works. And of course, this one works. Because we've already been using this formula, we'll use this one for our example. Okay? So here's another example. So example, 72, 69, 66. A, what is the 5th term of this sequence? This time we're going down by 3, minus 3, minus 3. So to find the next term, 66 minus 3, that's 63. 63 minus 3 gives us 60. Be careful, 63 is not the answer. Instead, term 1, term 2, term 3, term 4, term 5. 60 is the 5th term of the sequence. B, write an expression for the nth term of the sequence. Okay. We can use y equals mx plus b. That's one way of thinking about it. M is the change. I'm going to use blue for m. M is the slope. That's the change. We're going down by 3 every time, so m is negative 3. Okay. B is the y-intercept. That's the 0th term. We have to go back 1. This is a1. So we have to go back to the 0th term. 69, 72, 75. Because we can go the other way, we have to add 3. So that's why B, the 0th term, would be 75. 72 plus 3. So our expression would be, we don't actually need the y equals, because we're looking for expression, not equation. So we can just write negative 3 n. We're not going to use x here, because we're looking for the nth term. Negative 3n plus 75. That's our expression. C, use this expression to find the 30th term of the sequence. Well, here's our expression, negative 3n plus 75. We replace the n with the 30th term. Okay. This means it's negative 3 times 30, that's negative 90, plus 75, that gives us negative 15. That's the answer. Okay. Finally, write a rule in words that can be used to find the next term of the sequence. We can use the words they gave us to find the next term of the sequence. You can write to find the next term of the sequence. Here's a sentence starter you can use. The sequence. We can, what are we doing? We're subtracting, right? So we can say we can subtract the last term. Well, we can use the word previous. Previous means the one before. Previous term by 3. Okay, I wrote this a little better, and that's it.